वेलकम वनक्कम सुस्वागतम जो बोले सो निहाल सस्रीकाल वालेकुम सलाम अस्सलाम वालेकुम. This is your Baba H.S.P. Everyone just do let me know that your Baba is audible and visible to all of you or not. Hey my dear friends. Hey everyone. Ki hal chal? Everyone fantastic. Now we are going today to start with alcohol, phenol and ethers. Today I will let you know the missing part of Ncert and the hidden part of Ncert. This chapter. But before I start, I would like to see in the chat section that everyone can hear me, can see me. If yes, I would like to see that everyone smash the like button. 1111 and Sahana H.S.P. always dedicated. Rest of the other friends, emojis I cannot see. What happened, kids? What happened? Where is my H.S.P. army? TSP Gaming, Shiv, Harris Khan, welcome, vanakkam. Good evening, Salvi Singh, good evening. Now, I think if once I'm properly audible and visible without wasting even a single minute, let me start this alcohol, phenol and ether. Now, as written over here, alcohol. If I ask you one question that alcohols, what do you think? Alcohols are acidic or basic? Phenols, so definitely I will talk about they are acidic or basic. But first of all, do let me know everyone, what do you think that these alcohols on your screen? Just see if I talk about alcohols and if I ask one question, these alcohols are acidic or basic? Do let me know. They will start the question from here only, My dear students, as the name of chapter is getting started, do let me know in the chat section that alcohols are acidic or basic. Fast, quick. So, the answer here is your alcohols. Before I write about alcohols, I would like to see the answer from you people. What do you say that alcohols are acidic or basic? Everyone, quick. Do let me know everyone that alcohols are acidic or basic. Just do let me know your alcohols are acidic or basic. Before I start, I would like to ask from you people only, a less acidic than phenol. Wow, shall we saying that's really awesome. Less acidic than phenol. So let me first of all tell you that there is, if I talk about alcohols are acidic or basic, for this I would like to say one thing, my dear students, that methyl alcohol is the alcohol. Methyl alcohol is the alcohol which is more acidic than water. Remember that this is more acidic than water. So whenever you compare the acidic strength or basic strength, always compare with water. Rest of all other alcohols are more basic as compared to water. One thing is clear, because everyone is going to get failed in this, so I don't want my students should get failed for this category. My dear students, let me tell you the data, experimental data. If I show you, it is 15.5. What is this 15.5? This is the pKa value. Less is the pKa, more is the acidic strength. Water is 15.7 and this is 16 to 18 pKa at 25 degrees Celsius. I hope that everyone got it. So rather than quantity, we should focus on quality, and I hope that all my dear students would have got it. Everyone is able to understand this point. Do let me know that yes sir, this point is absolutely clear. Now If I add something more over here, then I would like to see in this category where will you keep phenol? Where will you keep phenol? Then phenol will come over here. That means most acidic is phenol. So I will keep phenol to be here because its pK value is 9.9, that is approximately 10. And I hope that this is clear to all of you. If yes, I would like to see the green signal in the chat section that yes sir, it's very much clear. Now the question arises that what is this acidic character? So always remember that less is the pKa, less is the pKa value, more is acidic strength. And I hope this is clear to all of you. This is very much clear to all of you. 1111, Salvi Singh, Sahana, that's really awesome. Now, let me talk about alcohol. If I talk about particularly this ethyl alcohol. Now, my dear students, before I talk about ethyl alcohol, let me compare why alcohols are generally basic as compared to water and why phenol is more acidic than water. The reason, just remember that whenever water is coming in search of proton, water will say, hey, I will snatch your proton, I will snatch your proton, I will snatch your proton. So phenol will say, hey, thank you 1111, thank you. So phenol will say, okay, if you want to take my water, if you want to take my H plus, most welcome, you take it away. I have no problem at all. Oh, why so? Why so? Array, phenol said, you don't know. My conjugate base is being resonance stabilized. किसी के जाने से अगर सुख की प्राप्ति होती है तो उसको जाने दो, जाने दो. Sir, what happened to you? You are looking so old and weak. Ayyo, Rangaswamy, Baba is looking so old and weak also. Ah, lucky Shiva. Okay, very good. Now there is resonance. It is stabilized by resonance. This is the conjugate base. Shiva, you are absent, you are not punctual. That's why Baba has become old and weak. This is the reason that Baba is looking old and weak. It's because of you only. You are not regular. Now, if acid is going to donate its proton and its conjugate base is stabilized by resonance, that means more is the stability of conjugate base, more is the acidic strength of that acid. And if I say over here that over here the lone pair is, or the negative charge is localized, can't do resonance, no resonance, no resonance. So it is highly unstable. It is highly unstable, so it will not get formed easily. It is highly unstable, so will not get formed easily. So we say generally alcohols are basic and phenol is acidic, and that's why phenol is also known as, another name for phenol is carbolic acid. What I'm saying, kids? What is the another name? Everyone do let me know. Carbolic acid. Now once this point is very much clear, this charge is delocalized and that charge is localized. Now one question in front of you. Karim, welcome. One question in front of you. You are supposed to tell me about this compound. Tell me, this will term blue litmus red or red litmus blue in color. I will write here this compound is acidic or basic. Do let me know. Vinyl alcohol. This is acidic or basic. Its name is vinyl alcohol. Everyone do let me know that vinyl alcohol is acidic or basic. Everyone just do let me know what is your answer. Next P block, no. Tomorrow I will take coordination chemistry. It's a turn of inorganic chemistry. Tomorrow is coordination chemistry. That is NCRT line by line. Very good, very good, very good, Lucky Shubha. Very good. Now tell me answer, everyone. So the answer is, you see, once the water is coming, it will take away its proton. If it is going to take away its proton, then the negative charge will develop over here. So its conjugate base, can you see its conjugate base is resonance stabilized or not? You see that नेगेटिव चार्ज आता है तो आने दो, रेजोनेंस हो जाने दो, रेजोनेंस हो जाने दो. सो स्टेबलाइज्ड बाय रेजोनेंस delocalized charge. So declared it is acidic in nature. It is acidic in nature and will convert blue litmus red. Now so remember that one point should be very much clear in your brain. Always remember, nice haircut, thank you 1111, thank you. Now one thing you have to keep it in your brain. Whenever OH is attached with sp3 hybridized carbon, what I am saying, kids, if OH is attached on sp3 hybridized carbon, it is always basic in nature. It is always basic in nature, right? No need to cram because its negative charge will be localized. Now whenever OH is attached to sp2 hybridized carbon, what? sp2, anything which is being sp2, if it is attached to sp2 hybridized, then remember that this negative charge is delocalized and that is acidic in nature. One point is very much clear to all of you, my dear student. Just to let me know, is this point clear to all of you? Now, by keeping this thing in your brain, if somebody is asking one question, my dear students, if examiner is asking one question and that question is that what will you say, that aldehyde, if I say acetaldehyde is acidic, basic, or none of these. This acetaldehyde, first option is, and it is placed in any medium. If you say any medium, if I am taking acidic medium, basic medium, or neutral medium, any medium, or solvent, if I say there is solvent, some solvent is added. Now tell me, this first option is acidic in nature. The second option, it is being basic in nature, basic in nature. The third option, it is none, none. Do let me know what's your answer. Your acetaldehyde is acidic. Very good, Kareem, because it is having alpha hydrogens, 3 alpha hydrogen atoms, and it will undergo tautomerization, tautomerize. So you will get CH2 double bond CHOH, and you see that this OH is attached on sp2 hybridized carbon. So your answer is acidic. I hope that everyone got it. Everyone, it's clear to each and every one of you. Now one more question. If I say that what will you D option, Sahana H.S.P, and no, it is acidic. It is acidic. That's why I have not given D option. Now if anyone is asking what will you say, the ethyl alcohol is acidic or basic, everyone do let me know. Well known alcohol, people they are using for drinking purpose. Now tell me, this ethyl alcohol is acidic or basic? Yeah, Lucky Shiva, I will start. Now tell me everyone, this is acidic or basic? Ethyl alcohol is acidic or basic? Do let me know. I'm waiting for your answer. And my team, please provide me water. Shall we sing? D is not there. Only 3 options were given. Only 3 options For that option, only 3 options. So it was acidic. Okay. Now tell me, ethyl alcohol, basic. Some are saying acidic. That means this question is really awesome. This question is really fantabulous. That means, am I right? Question is, ethyl alcohol is acidic or basic? Everyone. Now, my dear students, it's both. It's both. Just see, if I place Na in front of it, this is Na, so Na is more basic than alcohol, more basic. So once Na is more basic, alcohol will act as acidic. It will lose its proton and it will convert into C2H5ONA and hydrogen gas will get released. So it is acting as acidic. Thank you, Lucky Shiva. Thank you. Now, my dear students, if you see at the same time, if you see that this ethyl alcohol, if it is treated with what? Something like acid, HCl. If I say it is treated with HCl, then what will get formed? Tell me what will get formed. What will get formed? So this alcohol, in place of, there it was acting as acidic, was acting as acidic. There it was acting as acidic, acting as acidic. Now tell me, Baba, nice handwriting. Oh, I got appreciation from Sahana. That means Sahana, Baba is doing hard work. Baba is improving himself. Now, my dear students, with HCl, remember that, no reaction. So people will get failed over here. People will definitely get trapped. They will say that alcohol is acting as base, but no reaction. So for that, if I say that if I place Lucas reagent, that I will let you know what is Lucas reagent, and then definitely reaction will take place and alcohol will behave as basic. Alcohol will behave as basic. Now, my dear students, so what should I say? Alcohols are basic. Ethyl alcohol is basic. Yeah, I've got water, Lucky Shiva. Baba has got water. So what should I say? Alcohol is basic, acidic or amphoteric. And let me show you this thing in your NCERT. Wow, sim champa in NCERT. Alcohols, acidic, basic. What the NCERT is saying. Let me show you, kids. Preparation and after preparation, physical properties, and after physical properties, chemical properties, they must have given C. See this point, everyone just focus. I hope that everyone, this is visible to all of you. Is this visible to all of you, kids? Now see this point, chemical reactions. Everyone just think about it. Alcohols are versatile compounds. They react both as nucleophile and electrophile. This point is to be noted, my lord. Electrophile and nucleophile. Have you ever seen in this way? Have you ever seen in this way that alcohols act as both electrophile and nucleophile? Have you ever given importance if in the examination alcohol was coming And if they would have asked for alcohol, my dear student, definitely you would have gone for alcohols either as nucleophile or as electrophile. And there you would have lost your marks. Am I right or not? Do let me know. I don't think that any single student would have gone for alcohol as nucleophile or electrophile both. Am I right, kids? Do let me know. Am I right? Now, how they are acting as nucleophile. Just see, if in front of it, thank you, Sana, if in front of it there is carbocation, this carbocation is having just 6 electrons in the valence shell. This carbocation, always they have just 6 electrons in the valence shell. So definitely all carbocations are lowest acid electrophile. So this carbocation is for sure electrophile, and once it is electrophile, then this oxygen is having lone pair, it will donate its lone pair, and the one who is donor of lone pair will behave as nucleophile. Am I right? It is donor of lone pair. Am I right, kids? Donor of LP lone pair, and this is acceptor, and the one which is acceptor will behave as electrophile, and the another one will behave as nucleophile. So one point is clear. Now this reaction has taken place, the bond between, now by this oxygen will get positive charge. Now oxygen will say, I can't tolerate this positive charge. Definitely oxygen will say, I am too highly electronegative, I can't tolerate this positive charge. So what will happen? Oxygen will withdraw electron from carbon, the carbon which can tolerate this positive charge. So definitely you see what will happen, that either the proton will eliminate out or the bond will be broken. The two options are possible, that carbon oxygen bond, the bond between carbon and oxygen is broken when they react as electrophile. Remember that this point. My dear students, are you getting my point? Just do let me know. Kids, do let me know that whenever alcohol is behaving as what? Nucleophile, then the bond between carbon and oxygen is broken and they react as this. Now I think this point is clear. Now I think when alcohol is acting as nucleophile or alcohol is acting as electrophile, when the bond is breaking, let's see. This point, the second point, is falling under the category of that alcohol is acting as electrophile or alcohol is acting as nucleophile. That we have to see, right, kids? Are you getting my point? Now see, protonated alcohols as electrophile. Ayyo Rangaswamy, bhaiya. Normal alcohols, if simply nothing is given, then normal alcohols behave as nucleophile. Protonated alcohols will behave as electrophile. So remember the language of Ncert in your examination. Clear, kids? Simple alcohols will behave as nucleophile and protonated alcohols will behave as electrophile. Now this point is very much clear. So once this is clear, reaction involving cleavage of OH bond, what they are saying, cleavage of OH bond, that means this bond cleavage they are talking about. Acidity of alcohol and phenol. So the correct word in place of acidity, there must be acidic strength. They could have written it to be acidic strength. That would have been better word. Now see, whenever alcohol is coming in contact with sodium, it will form sodium alkoxide, which is used during Williamson synthesis of ether. Is it clear? Williamson synthesis of ether. Now, aluminium, which elements they are taking? If you remember, like Baba sir, can soda do magic? Where I taught you like Baba sir, can soda do magic? और इन हिंदी लिखवा सर का नाम अल मंजन कर फेंक दो निशाने पर बैठा हेलो कुए जी इलेक्ट्रोकेमिकल सीरीज these are highly reactive elements. They have potential to donate electron. They are very good reducing agent, very good reducing agent. Am I right, kids? Very good reducing agent. These are really very good reducing agents. So their tendency is to donate electrons. So the front, whatever is there, that will accept electron. Now see, sodium is donor, sodium phenoxide, all they are forming very, very strong nucleophile which will be utilized in your Williamson synthesis Williamson synthesis of ether. Now see all these reactions, you know very well. Now here they were talking about acidity of alcohol. If you see, they were talking about acidity of alcohol, acidity of alcohol. Have you seen, kids? Now the reaction, if I talk about acidity of alcohol, acidity of alcohol. Now see, which alcohol is maximum acidic? If I talk about primary alcohol, secondary alcohol and tertiary alcohol, what will you say? Everyone just do let me know which alcohol is being maximum acidic. So your answer should be primary. The acidic strength order is in this way. Remember that this is the acidic strength order, and that is, my dear students, that is the basic strength order. This is your basic strength order, right? One side acidic strength, another side basic. That in the starting I taught you, Kareem, that methyl alcohol is the only alcohol which is more acidic than water. But normally if we talk about alcohol, so remember that this is the acidic strength and that is the basic strength. I hope this is clear. This is your acidic strength and that is your basic strength. Is it clear, kids? Now that's why whenever you do Lucas reagent reaction, then tertiary alcohols react immediately, because tertiary alcohol, you know that Lucas reagent is acid, that is an equimolar solution of concentrated HCl and ZnCl2. So with the Lucas reagent, which will react fastest, tertiary alcohol. Tertiary alcohol is most basic. But what is the reason? The hidden part of Ncert, that why tertiary alcohols, very good, you got it, Kareem, you got it. So let me write down what Kareem is saying. So let me write down that thing over here, that if you talk about the strength, so we can frame out that most acidic is phenol, most acidic is phenol, then after phenol methyl alcohol. Both of them are more acidic than water, and then it comes primary alcohol, that is 1 degree alcohol, then it comes 2 degree, then it comes 3 degrees. So this is the flow chart, you can say, you can keep it in your brain for best marks, my dear students. I hope this point is very much clear. If you want to see boiling point order where? I will share one video, right? Tonight or tomorrow morning, I will share one video about that boiling point, okay? Now, my dear students, if I talk about their pKa value, then you will understand what Baba is talking about. The pKa of phenol you can take is to be 10, 15.5, 15.7, 16, ranging to 18. Less is the pKa, more is the acidic strength. More is the pKa, more is the basic strength. I hope this much is very clear to all of you. In this way, you have to remember, right kids? Right kids? Right. Yes, 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 my dear students. Very good. Now you got it. Now, let's see. Let me come back to the NCRT. What NCRT is talking about. What NCRT is explaining. Yeah. The question was hidden part of NCRT, which I was about to tell you. Why tertiary alcohol is most basic. Let's see the reason. Assertion reasoning, they can ask one question. Let's see, everyone. If I say that I am provided with tertiary butyl alcohol, what gets? If I say that Baba is provided with tertiary butyl alcohol, this is maximum basic in nature because it is 3-degree alcohol. Now, how to find out? See, this oxygen is having lone pair. How speedily this oxygen is going to donate its lone pair? We will say that is more basic. How easily it is going to provide a lone pair? My team, please close the door. My dear friends, now you see this methyl is plus I donating electron. This methyl is also plus I donating electron. This methyl is also plus I donating electron. All three plus I donating electron. So electron is going towards oxygen. Now this electron is reaching on the oxygen, so oxygen will be the best donor of electron. Maximum electron density, maximum electron density on oxygen, maximum electron density on oxygen, my dear students, maximum electron density on oxygen. So oxygen has become maximum electron rich. Oxygen has become maximum electron rich, and maximum electron rich oxygen, maximum electron rich oxygen, maximum electron rich oxygen can donate its electron very easily. So best nucleophile, I would like to say it is best nucleophile as well as it is best base. It is best nucleophile as well as base, but my dear students, remember that if I say it is best nucleophile, then it can attack only least sterically hindered carbon. Steric hindrance is too much. So with everyone it cannot behave as a nucleophile. Steric hindrance is too much, so it is not employed as a nucleophile. So generally not considered as nucleophile. But yeah, very strong base. It is very strong base. So because of its maximum basic strength, yes, 11, you are right. So because of its maximum basic strength, it will react with HCl also. That is the $1,000,000 question for your examination, kids. Hey, that Rangaswamy, they will ask this question in the examination, my dear students, that which alcohol can react with HCl? Neither 1-degree alcohol nor 2-degree alcohol. It is only your tertiary alcohol which can react even with direct HCl. Shaking with HCl, it will react, kids. Are you getting my point? It is so much basic. That it can directly react with concentrated HCl, shaking with concentrated HCl. So remember that tertiary alcohols are the alcohols which reacts with HCl, shaking with HCl. Kids, are you getting my point? Shaking, give me that bottle. Blue one. Oh, that bottle. See, simply if you add sugar to this water, that will not get dissolved. Summers are around the corner. In UP, people make shikanji. I don't know at your place what you call it, nimbu pani, lemon, limika. So, this is known as shaking. Have you seen the shaking with concentrated HCl? If you shake it with concentrated HCl, not simply with HCl, you are supposed to shake it, handshake. So, shaking with concentrated HCl, shaking with concentrated HCl, it will show turbidity. What is turbidity, kids? Is there anyone who can let me know what do you mean by turbidity? That the transparent solution will convert into translucent solution. You will get translucent solution. Why? Who has produced this turbidity? Who's responsible for producing turbidity? That is the tertiary alcohol got converted into tertiary butyl chloride. That means reaction would have taken place. Now the alcohol got converted into chloroalkane. This is the indication, because we cannot see the alcohol. You're not supposed to drink it. If anyone is saying, oh, I will taste it by drinking, ayyo Ranga Swami, that is not allowed in chemistry. Eating, drinking, touching is not allowed. Only seeing, or you can smell it a little bit, that is allowed. That means your alcohol got converted into chloroalkane. So either you shake with HCl or you simply react with Lucas reagent. What is Lucas reagent, kids? Is there anyone who can let me know what do you mean by Lucas reagent, kids? What do you mean by Lucas reagent? What is the meaning of Lucas reagent? So everyone remember that Lucas reagent is anyone? Is there anyone who can tell me that Lucas reagent? What is Lucas reagent? Do let me know. I'm waiting for your answer. What is Lucas reagent? So Lucas reagent is an equimolar no yeah I will, Prashad, I will. Equimolar solution of concentrated HCl plus anhydrous ZnCl2, right? Now, my dear students, let's see the NCERT. Acidity of phenol. Remember that. Why the acidity of phenol is there? We all know that phenol is acidic in nature. Can you see? Acidity of phenol. Definitely they will give you question based on acidic strength of phenol. The acidity of phenol. Here they will frame out the question, my dear students. And remember that while you are studying, do not show any diversion. Just focus on your studies. Right, kids? Everyone, and reply as soon as possible. Now, whenever I am having phenol, remember that if you put phenol in water, Definitely, what will happen? Phenol will form phenoxide. Then tell me who is, they will ask who is more stable thermodynamically, who is more stable, phenol or phenoxide? So remember that this is $1 million question. $1 million question, that phenoxide is thermodynamically more stable. Phenoxide is thermodynamic. I will come to this point, but before coming to that point, let me explain it over here. Just see what they are writing. The reaction of phenol with metals, sodium, aluminium. Why they have written sodium, aluminium? They could have written lithium, sodium, potassium, whatever the elements which are placed above hydrogen in the electrochemical series. That means highly reactive elements. They will react with this phenol. Even lithium will react with this phenol. Are you getting my point? Any element which is a very good reducing agent, like Baba's can soda do magic, like LIKBACRCA, then all they are reactive elements. They will form. Sodium hydroxide indicates it's acidic in nature. The hydroxyl group directly attached to sp2 hybridized. This already I have told you, sp2 hybridized will act as this. Now, my dear student, this oxygen is having two tendencies. Surya, welcome. One way, it is withdrawing electron by acting as minus I. At the same time, it is donating electron to the benzene through plus M. Everyone, are you getting my point? The OH, if I talk about, my dear student, just focus. Right now, the king is phenol, everyone. Can you see this phenol? Is it visible? Now, oxygen is saying, hey, I will withdraw electron from you. Ayaya, inge va, electron inge va, come towards my side. And through minus I, it is withdrawing electron. Through minus I, it is withdrawing electron. Are you getting my point, kids? Through minus I, it is withdrawing electron withdrawing in nature, everyone. That means oxygen is withdrawing electron towards itself side and making benzene to be less nucleophilic. Benzene is nucleophile. Benzene is like a millionaire. He is saying, hey, if you take a simple fractions of electron, that I am not going to become beggar. I will remain as rich, but my richness will decrease. Hey kids, its richness will decrease. Are you getting my point? Everyone, due to minus I, oxygen is acting as electron withdrawing group and it is decreasing the nucleophilicity of benzene. But at the same hand, its lone pair is saying, hey, I want to go towards benzene. This electron is going through plus M. That is also known as plus R, either plus M or we can say plus R. The electron is going to the benzene. This is known as mesomeric effect or resonance effect. So, by minus I, suppose it has withdrawn 0.2 electrons, but through plus M, it has donated 1 electron. Overall, benzene is getting benefit of how much? 1 minus 0.2. 0.2, how much gets? Benefit of 8 electrons. I am not saying that exactly it will be 8. It can be anything, but overall, benzene is in benefit and benzene has got more electron and benzene has become more nucleophilic. I hope everyone is getting more nucleophilic. So its nucleophilicity got increased. Because mesomeric effect is dominating than plus M effect is more dominating than what? Plus M effect is more dominating than minus I. Here plus M is a dominating effect than minus I. I hope you got it. Everyone, is it clear? This point is clear. Now see, the NCERT will say the same thing over here. I hope you got it, kids. Now, this point I would like to bring to your kind notice, kids. Just see and focus over here on this point. Everyone just see to it. This point, this holds a hell lot of weightage, and the examiner will definitely ask this question. Examiner will definitely ask this question, kids. Everyone just focus on this point. Everyone, you have to focus on this point. Are you ready, kids, for this point? This is $1,000,000 point, that phenoxide ion is more stable and favors the ionization of phenol. Although there is charge delocalization in phenol, but phenoxide is more stable, thermodynamically more stable. How many of you want to know why it is like this? Kids, do let me know why it is like this. How many of you want to know the reason? Do let me know. How many of you are interested in knowing the reason, kids? Tell me, kids. So, Baba is going to give you the reason, and that will be for your examination most important thing. Are you ready, kids? Just see. Thermodynamically, phenoxide is more stable. Let's see the reason. See, if I draw the phenol, just focus over here. If you add water or any base, definitely that will snatch its electron and will shift the equilibrium more in the forward direction, kids. Ready, kids? I can't see everyone's message. In this way, if everyone is not putting green signal, Baba will not tell you, kids. I will become angry on you people. I will stop each and everything, kids. If the things are not moving in the right direction, now kids, see, the water will snatch its proton and phenol will not say anything to water. Why, kids? Why, kids? See, everyone, the phenoxide formed is resonance stabilized. Phenoxide form is resonance stabilized. Now $1,000,000 question is coming, and definitely one day you will ask that, sir, even in phenol the lone pair was doing resonance, it was also stabilized by resonance, so what's new, sir? Nothing is new. There it was doing resonance, here also it is doing resonance. Then why the equilibrium is more lying in the forward direction and why it is lying less in the backward direction? That is the $1,000,000 question. Baba, what happened? Baba was waiting for everyone's response, but everyone was not responding. Only few people are responding. Then Baba will become angry, na? Baba is giving you the best. Only 11, Sahana, H.S.P, and some people are giving answer. Rest of others, they are not giving answers. They are not showing their reaction. Then Baba will become angry, na? Now, both are stabilized by resonance. First of all, let me tell you its another names. What are another names? It is phenoxide, Another name, kids, it is phenolate. It is phenolate. What is another name, kids? It is phenate. It is phenate. There are three names, kids, for this compound. There are three names for this compound: phenoxide, phenolate, phenate. Remember these three names, kids. Any name examiner can give you in the paper and you will get trapped. Now, thermodynamically, yeah, shall be is regular. Yes, 11. Sorry. Shall be. Sorry. Shall be is regular, and other students are also regular, but I was not having that meaning. Shall be, forgive me, please. Bahava was not having that intention. I said few students, but yeah, I have forgotten to take name of shall be. Working, but here, yeah, it started. Now there was lag. Mr. Lag was there, kids. Mr. Lag was there. Mr. Lag was there. Now, thermodynamically, phenoxide is more stable. What is the meaning of this? That phenoxide is thermodynamically more stable, kids. Thermodynamically more stable. What is the meaning of this, kids? That means thermodynamics is saying whatever the time it is going to take, how much time it is going to take, that's another thing, but phenoxide will be more stable. Now, what's the reason? This is the hidden part of NCERT. I would like to say this is what? This is the hidden part of NCERT. Why it is like this? So, are you ready to see the reason, kids? Everyone, are you ready just to go for the reason why phenoxide is thermodynamically more stable, why the equilibrium is favoring more towards forward direction, why it's delta G negative, delta G is negative, and why the equilibrium is being more shifted towards the right hand direction. How many of you are ready? Okay, 11, shall we sing? Ready? Very good. This is the way. It's a resonance hybrid. Okay, the resonance hybrid of phenol, it's like this. Just see, if you know the resonance, you can recall it, that negative charge, partial negative charge is at ortho and para. This is the true structure of phenol. Am I right, kids? Resonance hybrid, even I can say it is the resonance hybrid of phenol. Madhavi, welcome. Resonance hybrid of phenol, right? Am I right, kids? It is the resonance hybrid, or I can say the true structure. It's the resonance hybrid, or I can say it is the true structure. Everyone, either the word I can use resonance hybrid, or I can use the word that it is true structure, right, kids? Resonance hybrid or the true structure, I can use the word true structure. Now, if I draw, my dear students, the resonance hybrid or the true structure of phenoxide, just see, it was behind me, so you see this is the structure. This is the structure, kids. Can you see, is it visible to all of you? It was just behind me. So, canonical, no, it's not canonical structure, no. Canonical structure is one of the structure out of those resonating structures. This is the one structure which is indicating, which is carrying all the properties of canonical structures. A single structure having all the properties of resonating structures or canonical structures. You got it? Now let me draw phenoxides resonating structure. These are the resonating structures. Equilibrium is more towards phenoxide, and let me draw phenoxide's true structure. Just see, partial negative at ortho, partial negative at para, partial negative at ortho, and see this is having oxygen partial negative charge, and it's like this. First of all, everyone, you should be very much aware of the resonating structure. So this is the resonance hybrid, I can say. Either I can say resonance hybrid, or I can use the word true structure, right? Or true structure. Now, my dear students, can you see anything? Now see, there are two words, there are two terms which I will use, and that means examiner can also use those two types of words. First word that NCERT has used, that in phenoxides, that is right hand side is phenoxide. In phenoxide, there is no charge separation. There is no charge separation, my dear students. There is no charge separation, my dear students. There is no charge separation. No charge separation. Now, what is the meaning of this? No charge separation, kids. There is no charge separation. The NCERT has used this word, that there is no charge separation. Is there anyone who can let me know the meaning of this word, that there is no charge separation? What is the meaning of this word? That means this oxygen is having negative charge, and all the carbons, they are also having negative charge. That means everyone is having negative charge. That means no one is pulling the electron towards itself side. There is no one who is pulling electron towards itself side. If on the oxygen there would have been positive charge, just like on the left hand side, this positive charge is saying, hey electrons, come, 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 mere paas aa jao, come on, inge va, evde va, inge va, come, come, come. No one is there to call them near to them. If I say that everywhere there is Champa, if I say this is Alia, if I say this is Alia, and they are being Champa, so Alia and Champa, they are repelling each other, they are not calling anyone near to them. But here if I say this is Pandu, and they are being Champa, so Pandu will say, hey, come on, come on, come on, Champa, let's have friendship, let's have friendship. So Champa will go near to the, Champa will go near to the Pandu, and there Alia and Champa, they are not calling, they are hating each other. This is Alia, and Alia is saying, hey Champa, just remain away, poda. Just go away from here. That is the meaning of that. Champa and Alia, repulsion, and here Pandu and Champa, attraction. Ayyo Ranga Swami, I hope everyone got it. I hope that this analogy everyone is able to understand. Pandu and Champa, they are having force of attraction, and there Alia and Champa, there is force of repulsion. So that structure is more stable. Everyone got it? This technology, this methodology, this pedagogy, I hope that everyone is able to understand that why NCERT has used the hidden line, that it's not having the charge separation. It's looking like easy peasy lemon squeezy, I hope, my dear students. Now, the another term, if you see with the eagle eye, another eagle eye, that, can you tell me, rest of the things are same. The benzene is having same atmosphere. That one in left hand side, the oxygen is having positive charge, and the right hand side, oxygen is having negative charge. So negative charge is more stable on more electronegative atom, on less electronegative atom. Or I can say on more electronegative atom, which charge is more stable, negative charge or positive charge. That's it. That is the thing, kids, which you have seen, which I taught you in GOC, that which charge is more stable on more electronegative atom. The negative charge is more stable on more electronegative atom or the positive charge. Negative charge is more stable on more electronegative atom. So remember that this is the only point which I would like to tell you why this compound is more stable, because negative charge is more stable on more electronegative atom. Are you getting my point? The only thing that is negative charge is more stable on more electronegative atom. Is this clear to each and everyone? Now I hope this is clear. Let's go back to the NCERT. So this point is very much clear. Now this table holds a hell lot of weightage. pK values of Phenol and ethanol. Ready? Because in the examination they will give you question. Now people will think about that this question is from GOC, but this question is from very good. Size is same because both are oxygen, so size is approximately same. Wow, 1111, you have stolen my brain heart. Wow, great. Thank you, 1111. Now you are doing raw awesome performance. Your performance is really superb. Now let's come to this point. Now some people will think about that this question, if they are asking this question, they will say this question is from GOC. Some other will say that this question is from alcohol, phenol and ether. But question is question, that is from anywhere. So ready? Now see, once they are asking question from phenol, always remember that pom, pom, papa, pom. Para, then ortho, then meta-nitrophenol. Always remember pom, pom, papa, pom. The trick is, Baba has already given the trick, and the trick is pom, pom, papa, pom. Para, ortho, then meta, and then phenol. This is the acidic strength order, okay? Always remember that. Para, ortho, meta, pom, pom, papa, pom, and then phenol. If you want to see the value, if I tell you the value, experimental value, then the experimental value only a slight difference in pK 7.14, 7.24. See, very slight difference, 8.34, and that is 10. Is it visible to all of you? So if you see here a very slight difference, that if I don't know the experimental data, even Baba can get confused. These are experimental data, my dear students. Experimental data. Are you getting my point? Is everyone getting my point, kids? Now, why ortho is looser? In ortho, there is intramolecular hydrogen bonding. Remember that? Ortho is a loser because of intramolecular hydrogen bonding, and we people call it chelation. We people call it chelation. Due to chelation, its hydrogen is not going to lose or going to get away from it easily. This is involved in intramolecular hydrogen bonding. In case of orthonitrophenol, it is involved in what? It is involved in chelation, that is intramolecular hydrogen bonding, and that's why it is being looser. So remember that pom, pom, papa, pom, carboli. intramolecular hydrogen bonding, intramolecular hydrogen bonding, intramolecular hydrogen bonding. I hope everyone got it. Everyone got it. Intramolecular hydrogen. Now let's see what I have written. The NCRT is also writing the same data or not. Very good, Shalvi Singh and 1111. You are very much dedicated. Two people, TSP Gaming as well. Now see, pom. In para-nitrophenol, if you see 7.1, 7.2, 8.3, there is very slight difference. Most of the people will get failed in the examination if I talk about. Now, phenol is 10. Whatever Baba has given the values, they are writing the same values now. The question comes, what is Cresol? Cresol, what is Cresol? They have written Cresol also. What is Cresol? So definitely when you add methyl on phenol, it will become Cresol. Whenever you add methyl on phenol, it will become Cresol. Ortho, meta and para. What do you think which is supposed to be most acidic? According to you, which is supposed to be most acidic? Now see, if I talk about their pKa value, all of them are less acidic than phenol, because in phenol ortho effect is not possible. Remember that in phenol there is no ortho effect. If they would have been in benzoic acid, then it would be no, shall we sing benzene OCH3? No, that is anisole. Shall we sing that is anisole? Let me write down. Whatever you are talking, that is anisole. Remember that. Most of the people are losing the examination because of the journal names. Once the journal names is not clear, you are going to lose the exam. Remember that. Cresol is OHCH3, orthocresol. This is Cresol. Whatever you are saying, shall we sing, that is anisole. No ortho effect in phenol. Yes, remember that, otherwise also you will lose your marks. Now, you apply your brain. You apply your brain. Now, my dear students, one thing is not clear to me. Should I tell you which thing is not clear to me? Let's see. These all are ortho, meta and para Cresol. Now, if I show you the NCRT, one point is not clear to me. What is that? Just see. Meta Cresol, just see the NCRT kits. You will be shocked. Meta Cresol is less acidic than phenol. But if I apply theory, what our theory says? Our theory says that in meta Cresol there is minus I, and due to minus I it is withdrawing electron, and if it is withdrawing electron, so it will withdraw electron, charge will decrease, and this one is supposed to be more acidic than phenol. According to our theory, what we know, the theoretical way, this says that it is supposed to be more acidic than, it is supposed to be more acidic than what? More acidic than phenol. Because my dear students, there is just minus I from meta, unless minus I is applicable. But here, oh, I have done wrong. Sorry kids. Everything is right. This is more acidic, but I have written wrong. Chi. Come and beat me. OCS3 I have written over here. O will not be there. Sorry. That's why this I have done wrong. Sorry kids, I'm really sorry. Extremely sorry. This I have told you something wrong, kids. I'm extremely sorry, kids. See, I have done the same mistake as why teaching to Shalvi Singh, that Shalvi Singh it is anisole, and in that go only I have drawn anisole only, and that's why I was thinking something wrong. See, Baba did mistake. Here is CH3. Here is CH3. Baba is supposed to add CH3, but Baba has added OCH3, and that's why I was saying what is happening. Kids, have you forgiven me? Everyone, have you forgiven me? Have you forgiven me? Baba is so sorry. No, Salvi Singh, you don't say sorry. Baba is feeling sorry. Now, everything is right. First thing, remember that in phenol there is no ortho effect. There is, if somebody is applying ortho effect, he or she will get failed. There is no ortho effect in, there is no ortho effect in phenol. Remember this point. Will you keep it in your brain? Because this may become dangerous and people may get failed over here. There is no. There is no SIP. Neat aspirant. No SIR, no SIP. Remember that. People are getting failed because of this only. No SIR, no SIP over here. No SIR, no SIP. No SIR and no SIP. Will you keep this thing? No ortho effect in phenol, no SIR, no SIP. Will you keep this point in your brain, kids? Everyone does. Do let me know first of all that yes, sir, I will always keep this point in my brain. Otherwise, people may get failed. Now see. It is applying plus H, and remember that in phenol the negative charge is on the head of this oxygen, and due to plus H it will put negative charge and negative charge at orthopara, and this charge will get destabilized, means will increase. Charge will get increase due to plus M. This is plus M, and charge will increase due to plus I as well. Am I right? This is due to plus M, and here is due to plus I. Charge will get increased. So too much charge got increased. Now from meta no hyperconjugation, only plus I is valid. So the effect of plus M is 0 from meta because it is not applicable, and due to plus I the charge will increase 2 points. Charge will get increased 2 points, and from para plus H is applicable. So due to plus H charge will increase 4 point as in the starting. Now you see which oxygen is having least plus charge. That is going to be most acidic. All these are cresols. Which oxygen is having least charge? So only meta is having least charge. So meta will be most acidic. After meta it should be para, and after para it should be ortho. And from all these, phenol is on number 1. Phenol is maximum acidic. Am I clear, kids? Have I made it very much clear to all of you, kids? Do let me know that this point is very much clear to each and everyone. Then only I will go to the experimental data. Just see everyone, this is clear. Meta, para, ortho. Cresol. Nitrophenol to everyone teaches. Wow, 11. Shall we sing? 2 kids are to really very much regular, fantastic, super awesome. Do let me know, my dear students. क्या सबको समझ में आया? Then only I will go to the experimental value. Now see, let's see MPO. MPO MPO. See, phenols 10, then M is 10.1, then P 10.2, O 10.2. See, in NCERT both are written 10.2, but the second digit will be in favor of MPO. See the NCERT smartness of NCERT, here also 10.2, here also 10.2, but we know very well that which one is more acidic. MPO is the order. MPO. Is it clear to all of you kids? Is it very much clear? And then last is alcohol 16. I have told you 16 to 18. So it's like this. You can see to it. I think this point is very much clear. NCRTs, these points you are able to understand. Everyone got it, kids? Do let me know in the chat section. Show me green color if it is clear to all of you. If it is very much clear to each and every one of you, do let me know in the chat section. Quick, quick, quick. Mummy, Papa, Oxygen. Wow, let me see. Mummy, Papa, Oxygen. 11. Very good. MPO. Wow, Mummy, Papa, Oxygen. Wow, very good. Now, salicylic acid. We all know that salicylic acid will produce aspirin. This the whole world knows now, my dear friends. We know that alcohol loses proton, but have you ever seen that alcohol is losing OH? The reactions where alcohol's OH bond cleavage is taking place. Let's see. These are the reactions. Reaction with hydrogen halide. This is Lucas test. We know very well. Lucas test. Phosphorus trihalide. Dehydration. The whole OH will go, right? Now, my dear friends, if you see this reaction, very well known reaction, everyone just see. If I talk about phosphoric acid, this is 2-degree alcohol, this is 3-degree alcohol. If I am saying which will require more acidic, phosphoric acid is definitely water snatcher. It will work like H2SO4 or even better than H2SO4. It will snatch water. पानी को खींच लेती है H3PO4. पानी की प्यासी है H3PO4. Even बड़े बड़े पानी के प्यासों का पानी खींचने वाली है H3PO4 phosphoric acid. Remember that. It will snatch water. Now, which is more reactive, 3-degree alcohol or 2-degree? Definitely 3-degree alcohol is more reactive. So less concentrated phosphoric acid is required. See, here 85%. Have you ever seen 85%? Here just 20%. Have you ever seen? Have you ever seen, kids? In one case, just 20% phosphoric acid and even less temperature. See, less concentrated, less temperature. More concentrated, more temperature. Have you ever seen in this way? Your NCERT, have you ever seen in this way? More concentrated phosphoric acid and more temperature. Less concentrated phosphoric acid and less temperature. This is the most important, the hidden part of NCERT. The examiner will definitely ask this question, kids. Everyone, superb. So mark my words, keep this in your brain. Now, relative ease of dehydration. They have written tertiary, secondary and primary. They should have mentioned one thing. What is missing over here? The missing part over here is that if anywhere, if you see aldol is going to lose very easily. Aldol is on number 1. The best water loser is aldol. Aldol is beta hydroxy carbonyl compound, beta hydroxy aldehyde or ketone. This is beta hydroxy aldehyde or ketone, aldol. Beta hydroxy aldehyde or ketone. I hope you got it. That is on number 1. Now, kids, 1 minute break. Let's talk to you in this 1 minute break. You're feeling bored or okay? Do let me know you're feeling bored or okay. Yeah, aldol, then tertiary, then secondary, then primary. Telegram link. Wow, thank you. Thank you. This is the thing, that Telegram. Always I'm sharing number of things. Most important thing on Telegram. So everyone is supposed to join the Telegram, and that is the most important thing, kids. Now anything new you want to ask, kids? Anything you want to ask to Baba, that Baba, what should I do, what I'm feeling like that? Kids, not getting bored. Very good, shall we sing? That's really awesome. Rest of other students, do let me know how you're feeling now. Tomorrow, coordination chemistry, 11 coordination chemistry, NCERT wise. NCERT wise coordination chemistry. Line by line. Shalvi Singh is enjoying, Harni Singh is enjoying. Rest of other students, do let me know, kids. Baba want to know that everything is okay, because whenever we are studying too much, our hippocampus, our brain is not that much active. So we have to take 30-second screen off. We have to talk to each other. We have to take rest for a while just to regain our energy back. Kids, you are the backbone. You are going to become doctor, definitely. No one can stop you to become doctor. Let's see how much good you can do in your examination. Cool, calm mind can definitely result in a better thing, better way, good result, my dear students. Are you getting my point? Everyone, just to let me know. Hey, everyone. Yay, rocking. Do some exercise. Yeah. Now. Done? Done some exercise? Yes, Harni Singh, Baba is always with you people, for you people. Shall we sing? Very good, very good. Now, always remember, let's come back, always remember that whenever you provide low temperature, it favors substitution reaction, and whenever you provide high temperature, it is going to favor elimination reaction. So the same alcohol but two reactions. Just try to see, first of all, you just try to see. In one case it is forming ethene, and the another step they have not shown, but if the reaction is carried out at 413 Kelvin, it will form ether. That's why Baba always fit. Thank you. Now see what I am going to tell you, kids. What I am going to tell you, that at 413 Kelvin, ethyl alcohol will form diethyl ether, and that is known as Williamson's continuous etherification. Ethyl alcohol on reaction with concentrated H2SO4 at 413 Kelvin, it will form diethyl ether, and it is known by the name Williamson's continuous etherification. It's not Williamson's synthesis of ether, that's different reaction. Williamson's continuous etherification. Williamson's continuous etherification. And if the reaction is taking place at 443 Kelvin, 443 Kelvin, then your product is ethene. So temperature is the hero over here. Can you remember? At 413 Kelvin, ether formation taking place. At 443 Kelvin, alkene formation takes place. Dehydration. Is it clear? No. Oxidation, so we all know, but in oxidation, just remember that PCC. PCC is our hero. Who is PCC? PCC, if somebody is asking what is PCC, everyone will say pyridinium chlorochromate. But the correct thing you should know, PCC is 1 raised to 1 mixture of what? This mixture of 1 raised to mixture of what? Pyridine. HCl. CrO3. Remember that. All the three should be in the ratio of 1 raised to 1 raised to 1 raised to 1. Then only we will say it is PCC. Otherwise, we will not say PCC, and it is MOA. Very good. MOA means it will oxidize alcohol, that is 1 degree alcohol, to aldehyde, and the reaction will get stopped over there. Once 1 degree alcohol has been oxidized to aldehyde, the reaction, this is not PCC. If you use PCC or anhydrous CrO3, then the reaction will get stopped at alcohol only. And one more thing, very awesome thing, that is double bond will remain unaffected. This is important thing. No effect on double bond, my dear students. Double bond will not get affected. Double bond will remain as such. Now how to find out that this reaction is oxidation reaction? ये कैसे पता लगेगा कि ये रिएक्शन ऑक्सीडेशन ही हो रहा है? ये कैसे पता लगेगा? तो ये बात पता लगाने के लिए let's see. If I am having alcohol RCH2OH, if you see the oxidation state of carbon, this is electron donor, +1, so -1, +1, so -1, +1, so -1, and -1, so +1. +1 -1 cancelled out. Carbon's oxidation state is -2. In alcohol, what is the oxidation state of carbon? -2. Loss of electron means negative oxidation state will decrease. So if I talk about in aldehyde, just see aldehyde, RCH double bond O. Now see kids, +1, so -1, +1, so -1, -2, so +2, plus and minus got cancelled out. Carbon's oxidation state is 0. -2 to 0, that is what? -2 to 0, this is oxidation. Now if I talk about carboxylic acid, R, C double bond O, O and H. If you see over here, R is +1, so -1, -1, +1, -2, +2. If you see, then -1 and +1 cancelled out, +2. So from alcohol to aldehyde to acid, -2 to +2 it has gone. Can you see? If I talk about an alcohol, the oxidation state of carbon is what, kids? And aldehyde, the oxidation state of carbon is what? And if I talk about in carboxylic acid, the oxidation state of carbon is what? You can easily find out. Here it is -2, here it is +2, here it is 0. So definitely oxidation is taking place. I hope this point is very much clear to each and everyone that this is oxidation. Now, what I am going to tell you, if you use more, then it will do oxidation only up to aldehyde, and if you use more means mild oxidizing agent, right? Mild, what? Mild oxidizing agent. Now, if you use soa is strong oxidizing agent, then it will make reaction to acid. Soa means strong oxidizing agent. Everyone, are you getting my point? Strong oxidizing agent. I hope one point is clear to all of you kids. Yeah, now you have to find out what is MOA and what is SOA. So I'm going to give you a list and then we will see this thing in NCERT, right kids? Everyone? Unknown doctor, H.S.P sir has produced ranks. Thank you, unknown doctor, thank you. Now, let's see. Shirley started shouting. Now, see kids, let me draw one line. One side I will write down MOA, another side I will write down SOA, okay? Mild oxidizing agent, strong oxidizing agent. And mild oxidizing agent, the best one is, who is the best? PCC is the best. I'm the best, I'm the best, I'm the best. Or you can use CrO3, anhydrous, no water should be there. Or you can use, these two are for right now important. Here you can use CrO3 water, that will form chromic acid H2CrO4. Remember that. You can use Johns reagent. Have you ever heard Johns reagent? That is CrO3 concentrated H2SO4. You can use K2Cr2O7 concentrated H2SO4. This will also produce chromic acid. All three will ultimately produce chromic acid H2CrO4, that is strong oxidizing agent. Yeah, that's why I am making table. Now my dear students, you can use KMnO4 acidic medium, potassium permanganate acidic medium, or you can use concentrated HNO3, concentrated nitric acid HNO3. They all are being in your syllabus, right? Now, by keeping each and everything in our brain, I would like to focus at one place, that copper, silver, gold. If you provide high temperature, then they will behave differently. So remember that copper, silver or gold, you know that silver and gold, they are very costly. So examiner will not give you in your exam, very costly. They will give copper, they can write down 300 degrees Celsius temperature, they can write down 573 Kelvin. So they will react differently with different type of alcohol. That is the thing which is required. After completing this, I will tell you cleavage of ether and then the session will get over. Just after completing this cleavage of ether, because that holds a hell lot of weightage. Okay, my dear students, the cleavage of ether, which is really very important. Maximum people, they are losing their marks in the questions of cleavage of ether, right kids? Now let me come back to the NCERT. I don't know where the NCERT has gone, how to get it. My team, please help. It's gone somewhere. Yeah, thank you. My team is always helping kids. Now, you see, as I was telling you, that this one, focus over here. Is it visible to all of you kids? Is it visible? Remember that primary alcohol with MOA giving RCHO Rancho, as well as with copper they are giving Rancho. Secondary alcohol with MOA or SOA they are giving ketone. This is also giving ketone. But tertiary alcohol with copper will undergo dehydration to produce isobutylene. Remember that. Isobutylene. Thank you, shall we think? Thank you. Isobutylene. Dehydration. Here dehydration is taking place, right? Dehydration is taking place. Now, my dear students, phenol, you know very well, always I taught you that phenol, but remember that this phenol with dilute HNO3, remember that, ESR reaction. Are you ready? Everyone ready for ESR? Do let me know. Is everyone ready for ESR? After completing ESR, I would go with the ether cleavage, which holds a hell lot of weightage, kids. Cleavage of ether. Do let me know that everyone is ready. Okay, now see, definitely one question will come from here. Dr. Sachi, from where? Which place, Dr. Sachi, you are? Most welcome, Sachi. Now, remember that with dilute HNO3, the nitration will take place. But if somebody is asking, during this nitration, HNO3 is acting as an acid or base, do let me know, kids. Question is, during this nitration, HNO3 act as, do let me know, HNO3 will act as acid or base? HNO3 is acting as, do let me know, everyone. My question is here, Karnataka, very good, warm welcome. HNO3 is acting as acid or base? Do let me know. Let's see who is going to give the answer. During this nitration, you have seen that for nitration, nitrating mixture is concentrated HNO3 and concentrated H2SO4. But during this reaction, your dilute HNO3 is acting as an acid or base? Tell me. Let's see how many of you are going to rock in your exam. Otherwise, you will get failed. If you don't know this thing, this HNO3 is acting as acid or base. 11 is saying acid. Rest of others are saying base. How many of you want the answer from Baba? Pucho kyun? Kaise? Kya hua? और पूछो न पूछो ये क्या बनेगा, देखो देखो रे यहाँ पर, whether it will behave as an acid or it is going to behave as a base. Everyone, this is a $1,000,000 question or not, kids? Do let me know. Is it $1,000,000 question or not? Now, let me tell you, kids. What is this? What is the answer? Dilute HNO3 if you have taken. Dilute HNO3. Then HNO3 will say, hey, yeah, I'm the acid. I will donate proton, proton, proton. Now, it is behaving as an acid, as an acid. Now, those who said it will behave as an acid, they must be so much happy that, Baba, my answer is right, Baba, my answer is right. But the next moment, the acid can behave as an acid only when somebody is going to accept its proton. If there is no one to accept proton, then to whom this is going to donate proton? So another molecule of HNO3 is saying, ayyo, I'm ready to accept your proton. The proton you have thrown in the solution, I'm ready. I will accept your proton and I will convert into a compound like this. Ayyo Rangaswamy, you have accepted proton, so acting as base. तुमेव माता पिता तुमेव, तुमेव बंधु सखा तुमेव. You are acting as an acid, you are acting as a base, you are in double row. तुमने दी आवाज लो में आ गया, पर्वतों से आज मैं टकरा गया. Most people got trapped and now that they will do in the examination. Now, HNO3, you are acting as an acid, you are acting as a base, and oxygen is saying, I can't tolerate this plus charge. Okay, you can't tolerate. So what you are going to do, my dear? I will throw it out. Okay, let's see. I can't tolerate nitronium ion. Now if you add each and everything, let's see what is going to happen. Let's see. Baba always try to put trap. Arey Nana, this life is a trap. जब life हो out of control, tingling डके बोल, I am going to find out the reason. Yeah. Now it's the time to cut it. Ching ching ching. मेरा नाम ching ching ching. Wow. Cancer. That means during this reaction, how many moles of HNO3? How many HNO3 you are supposed to take excess of HNO3? That means 2 moles of HNO3 we should take. 2 moles of HNO3. 2 moles of HNO3 because one will behave as an acid, another one will behave as a base. la la la, la la la, la 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 la. Got it? So you got nitronium ion in this way. Nitronium ion has been produced. So if you are using dilute HNO3, then you will get orthonitrophenol and paranitrophenol. Both are the isomer. What type of isomer? Orthonitrophenol and paranitrophenol are what type of isomer? What will you say? They are what type of isomer? They are position isomer, structural isomer. Structural isomer, am I right? Now, you see, in orthonitrophenol, both type of hydrogen bondings are possible. Your orthonitrophenol can show intramolecular hydrogen bonding as well as intermolecular hydrogen bonding. But when there are two options, some people just go for one option, and it will also go only for one option. Position isomer is very good. Just it will form chelation, intramolecular hydrogen bonding. Why intramolecular hydrogen? It will give preference. Remember that whenever there are options, choices, then ring formation is always better. Why ring formation is always better? Whenever it is going to form chelation, in the starting it is one molecule. After intramolecular hydrogen bonding, it will remain one molecule. So change in entropy is approximately 0. But because of formation of bond, no ortho effect in phenol, yes, but due to formation of bond, delta H will be negative. When delta S is 0 and delta H is negative, you can see for intramolecular hydrogen bonding, always remember that for chelation, why I always say chelation is better, but during chelation, remember that ring formation should be of either 6-membered ring or 5-membered ring or 7-membered ring. No other ring formation will be favored. Remember that these rings are given preference. So during ring formation or chelation, delta S value change in entropy is approximately 0. Why I am saying approximately 0? Because there are a number of entropies like translational, degree of freedom, rotational, vibrational. So, and delta H because of bond formation is negative. So, actually who is controlling the reaction? Which reaction, sir? Gibbs-Helmholtz equation, delta G is equal to delta H minus T delta S. So, it is 0. So, the whole term will come out as 0, 0. So, actually the reaction is controlled by delta H, and that will come out negative. Are you getting my point? So whenever intramolecular hydrogen bonding is there, always give preference to intramolecular hydrogen bonding. Are you getting my point? The thermodynamics in your organic chemistry. Is there any teacher who is teaching thermodynamics in your organic chemistry? For that, teacher must know thermodynamics as well as organic chemistry. So always give preference to intramolecular hydrogen bonding. I hope this is clear. Ad is coming. Ad started. I asked YT not to give ads. I tried my level best, but I think my team must have started. Baba, hydrocarbon remaining part. So definitely on Monday or Tuesday I will take remaining part of 11 is very dedicated, and shall we sing? You two kids are so dedicated that I am not having a single word to explain. Really, you are rocking. You are near to my heart, brainy heart. Hats off to you. Whenever I see your name, Baba feel accomplished. Now, so when I go to the NCERT, remember that paranitrophenol will form intermolecular hydrogen bonding, and due to intermolecular hydrogen bonding, molecules will come nearer and they will come closer, and it is high melting solid. Remember that this question they will ask. Para-nitrophenol is high melting solid, whereas ortho-nitrophenol is volatile liquid, steam volatile, because it is not going to form a bond with others. And para-nitrophenol will form a bond like Bahubali, Mahendra Bahubali. It will accumulate all the people of village and it will say, come close, come close. So whenever you heat, it will not go in the vapor phase easily, because for that bond breaking is required and it will not break the bond easily. So some amount of heat will be required to break that bond. That's why you see orthonitrophenol is steam volatile due to intramolecular hydrogen bonding. Have you seen, kids? Everyone, have you seen? While para-nitrophenol is less volatile due to intermolecular hydrogen bonding. Can you see, kids? Everyone. Now it's a time for concentrated HNO3. When you do this reaction, and this is not going to give yield, will not give good yield, poor yield. Why, kids? Why it will give poor yield? Why it will give poor yield? The answer is HNO3 is oxidizing agent and it will do explosion. Picric acid is explosive and that picric acid will get exploded, so some amount will get destroyed. So nowadays how this is carried out, so it has given the challenge. Nowadays picric acid is prepared by, so Baba will let you know, and then Baba will move to cleavage of ether, then the session will get over, right? Now let's see, kids, nowadays how picric acid is prepared nowadays. They will take phenol, they will react with sulfuric acid or oleum, sulfonation. They will carry out sulfonation. So you know that sulfuric acid, it belongs to third period and it is more bigger in size as well as sterically hindered, so it will not easily form the bond and it will occupy two positions because it is too much sterically hindered, so it will not come at this ortho position. Now do the nitration. Once you do the nitration of this compound, you know that nitrogen belongs to second period, so it will come slowly because sulfur will say I need some time to go. So very slow reaction, very slow reaction. So slowly it will form picric acid and there will be no explosion, so yield will be very good. I hope that everyone got it, and this is known as picric acid because of 3 minus M minus I group. Its pKa value is approximately 0. It is highly acidic picric acid. Nowadays it is prepared in this way, right? So each and everything I have told you. One more thing I would like to tell you. Phenol when reacts with bromine water, remember that when phenol reacts with bromine water, where the reaction is given, phenol reacts with bromine water, it forms white color PPT of 2,4,6 tribromophenol. Where it is given, I think it's missing. How they can miss it? Yeah, they have given. You see 2,4,6 tribromophenol. 2,4,6 tribromophenol is white PPT. Same white PPT is formed by aniline also. Remember that even aniline gives white color PPT, right? Now if you carry out the same reaction in presence of catalytic poison, now what's the reason, the hidden part of Ncert? Let me tell you. When you treat it with water, the phenol on reaction with water definitely will convert into phenol, will convert into phenoxide, and now you see in phenol it is less electron rich. Why less electron rich? With minus I it is acting as electron withdrawing group, and with plus M it is acting as electron donating group. But if you see the phenoxide, once it got converted into phenoxide, then it is giving electron in all the ways, plus I as well as plus M. With all respect, it is giving electron to benzene ring. So phenoxide is more electron rich, or you can say its nucleophilicity is too much. That's why all the bromines, they are occupying ortho and para position, and bromine is having so many electrons, that means the molecules will come closer and they will form a precipitate van der Waals forces of attraction, and it will look like that's white in color. Chatra, good evening. Now if you add catalytic poison, why catalytic poison? It is known as carbon disulfide. So carbon disulfide will not change phenol into phenoxide. Once the phenol is remaining phenol, it is less electron rich, so it will allow bromine at ortho and para will be major. With this point, one point is coming in my brain. The earlier one, they have not written para-nitrophenol or ortho-nitrophenol, which one is major. Remember that due to intramolecular hydrogen bonding, ortho-nitrophenol here is 60% and para-nitrophenol is just 40%. Otherwise, in all other cases, para product is major because of less steric hindrance. But if you see, due to intramolecular hydrogen bonding, ortho is major product. Have you seen? This point was getting missed by your Baba. Now I think that you are feeling comfortable. Huh? Now this is okay, this is okay, everything I have told you. Now it's the reaction, that one is Kolbe reaction, very important reaction. How I can leave Kolbe? Some people also call it Kolbe-Schmidt reaction, and this is preparation of salicylic acid, very important. Phenol on reaction with NaOH acid base neutralization will form sodium phenoxide and carbon dioxide. This is ortho-para-diacting. So salicylic acid, that is ortho 1, and there is stabilization by chelation. That's why ortho is major and para is minor. So remember that para will also get formed, but that will be minor. Right, my dear students? Now I have told you each and everything along with this Riemann-Tiemann reaction. This I have explained number of times, that salicylaldehyde as well as salicylic acid will get formed, and dichlorocarbon is the intermediate. CCl2 is the intermediate of this reaction, dichlorocarbon. Now only one thing is left, that is cleavage of ether. Ready, kids? Zinc, so this everyone knows. Oxidation, everyone knows. This benzoquinone, this though we have seen number of times. So now are you ready for cleavage of ether? That is the last part of today's lecture. Is everyone ready, kids? Is everyone ready, kids? Do let me know. Now in cleavage of ether, the master stroke point is that you have to remember, then you will be able to solve all the questions. Mark my words, categorically Baba H.S.P is telling you this particular point, which holds really a whole lot of weightage, that whenever you are provided with ether, remember that any question of ether cleavage you can do very easily if you remember what Baba is saying. Ether cleavage. Are you ready? That you are provided with ether. Ether is always like C, O, C, and the valency of carbon like this, right? Now OR negative is a very strong base. Remember that, OR negative. Why it is strong base? Because if you add a proton to this, it will become acid. That is, alcohol is an acid, and that is weak acids conjugate base is stronger base. Weak acids conjugate base is stronger base, and stronger bases are poor leaving groups. So whenever you add a very strong acid like Hi or HBr, then H plus will attack on the lone pair of oxygen through acid base neutralization. Remember that, through acid base neutralization. This part I have started this chapter from here only, and now due to acid base neutralization, what will you get? You will get protonated alcohol. Do you remember? Do you remember? Oxonium ion. You will get oxonium ion. Now, $1 million question arises that carbocation will get formed or not. If carbocation is getting formed, we will say SN1. If not getting formed, then SN2. That's it. Now, it's not that easy that carbocation will get formed or not. For that, if you remember, I have shared one lecture, that is stability of carbocation. Those who know stability of carbocation, if you have seen, if you have gone through, if you have watched that lecture, you can easily do all the questions. You can easily solve all the questions. And if you don't know, अगर आप नहीं जानते हैं तो आपको दिक्कत होने वाली है, बहुत बड़ी प्रॉब्लम होने वाली. My dear students, if the carbocation either from the right hand side of this oxygen or the left hand side of this oxygen is getting resonance stabilized or having at least 8 alpha hydrogen, what I am saying, if you see this oxonium ion, मेरा प्यारा प्यारा बच्चा लोग, everyone, just see, if I talk about this oxonium ion, it is having 2 carbons. One is on the right hand side, another one on the left hand side. And remember that if any side the carbon is getting resonance stabilized, or it is having how many alpha hydrogens, or it is having 8 alpha hydrogen atoms, then the carbocation will definitely get formed. Carbocation formation will take place, and SN1. If no SN1, then SN2. Nowadays, godfather of chemistry. Wow. Thank you. In front of you, Shushmaryam. Shuhamaryam. Good name. Very good name. हाँ, अभी क्वेश्चंस कराऊंगा, बिल्कुल क्वेश्चंस कराऊंगा, डेफिनेटली. ये समझाने दो, इसके बाद क्वेश्चंस कराऊंगा, ठीक है. नाउ फ्रॉम हियर रिमेंबर दैट व्हाट आई एम सेइंग, केस नंबर 1, ऑलवेज सी द केस नंबर 1. इफ carbocation formed from any site is stabilized by resonance or having at least 8 alpha hydrogen atoms, then carbocation formation will take place. Remember that. Then carbocation formation will take place. And whenever carbocation is formed, always think about rearrangement. Always think about rearrangement. Chaitra, how I can forget you? Chaitra, Baba never forget anyone. How I can forget you, Chaitra? Now, whenever the carbocation is formed, attack of iodine will take place on carbocation. Remember that iodide will attack on iodide, will attack on carbocation, right? Carbocation will be attacked by iodide. Okay. If not SN1, then SN2. Remember that. If not SN1, case number 2. I will give questions to explain it. Case number 2. If not SN1, then SN2 will take place. Then who will take place? Either stabilized by resonance or at least 8 alpha hydrogen, right? If not SN1, then definitely SN2. And if it is SN2, then I will attack on least sterically hindered carbon. Then I negative will attack on least sterically hindered carbon. Least sterically hindered carbon. That's it. Now let's see how many of you can apply this. How many of you can apply it? Are you ready for the questions? Let's see how many people can apply this. Are you ready? If yes, show me green, green hearts or green color, anything green. Go green. Let me check it out. How many of you are able to understand? Question number 1. Ready? Yes. Tell me SN1 or SN2. That's it. If you are able to recognize SN1 और SN2 तो आप सभी लोग इस क्वेश्चन को इजीली कर पाएंगे। मेरे प्यारे प्यारे बच्चे लोग, अगर आपको ये समझ में आ गया कि SN1 या SN2, then no one can stop. Okay, Chaitra, you are watching recordings. Okay, no problem. Now tell me, SN1 or SN2? SN1, very good. 11. If you are able to understand SN1, then this is very, very important because this carbocation is stabilized by resonance. So directly you can solve this question. Form iodine bond over here and H over there. You can directly get the answer, my dear students. No need to write down anything. In the air you can solve this question. This will go with this and this will go with this. Just see to it, kids. Just see to it. It will go with this. So your answer will be benzyl iodide plus methyl alcohol. Everyone got it? First ABN and then SN1. I hope everyone is clear. This is clear to each and everyone. Second question. Yes. Now tell me, those who are really doing it in a better way, they can easily get it, solve it, everything gets fast. But I want to see the answer, quick response. You can do it in the air, kids. You can just do it in the air. SN2, 11, fantastic. Because if you see on the right hand side, no alpha hydrogen. If you see on the left hand side 6 alpha hydrogen atom, so no one is able to form carbocation. No SN1, no SN1 means definitely it is SN2, and in SN2 the I negative will attack on least sterically hindered, so this is least sterically hindered and this is, so your answer will be this is also clear. Now if they are going to give tough question, let's see how many of you can solve tough question. Question number 3 is a little bit tough. Tough is nothing if you know the things. Yes. Yes, kids. SN1 or SN2? Quick, quick, kids, quick. Wow, 11-11. You remember that day, the first day. You missed some questions, but now you're rocking 11-11, rocking. Upper part SN2, lower part SN1. Shall we saying two places ether is there. Upper part SN2, lower part SN1. Here this carbocation is having 9 alpha hydrogen atoms. Upper part nobody is having. So during SN2, the negative part will go to least sterically hindered I here, H here, and here, I here, H here. Can you get it? Now your answer will be OH, OH, ethyl iodide, and tertiary butyl iodide. So both SN2 and SN1, both SN2 and SN1, right? First ABN, SN2 and SN1 both. Now my dear students, the last point, last but not the least, are you ready for that? I would like to tell you something about cleavage of ether, right? One anaconda question and then something very good, right? One anaconda question. Anaconda means definitely you will attempt it, but you will get negative marks, right? Anaconda question. That means negative marks. Now, SN1 or SN2? No SN1. Wow, you have become, your eyes have become eagle eyes. 1111, now to you have become pro. What to say? No water. No PPS means no carbocation formation. Are you getting my point? Now once no carbocation formation means single step reaction. And single step reaction means I negative. Wow, I negative will attack on least sterically hindered. So here maximum people will get trapped, gets maximum people, 99.99% people are going to get trapped for this. Gets ready? Got it? Everyone got it? Everyone now. One note and then the class will get over, right? One note and then one question based on that, right kids? Now first let me give you one question. Question is allyl vinyl ether reacts with HI. SN1 or SN2? Allyl vinyl ether. Yeah. Fake academy. For this you should know the structure. Once you know the structure, then only you can think about something. So first you just recall the structure of this compound allyl vinyl ether. Then only you can think something about it. Yes, everyone. Baba is waiting for your response. SN1 or SN2? Yes, kids. Baba is waiting for your response. Yeah, see, Baba knows how to give questions because examiner will definitely give questions. See, allyl. Vinyl. Now once avian will take place, it will get proton oxygenated proton oxonium ion. Now from both the side, left hand side and right hand side, it will ask for electron. Now can you tell me which is resonance stabilized, the right hand side or the left hand side? Now this is highly unstable, cannot form its carbocation, but of the left hand side you see this is stabilized by resonance. Carbocation is stabilized by resonance, so definitely it is SN1. Very good. Shall we sing this time? Avian then SN1. Now shall we sing? Is giving the answer. So your answer will be what? The iodine will come to carbocation. So iodine will come over here and hydrogen will go over there. So your answer for sure is going to be allyl iodide. allyl iodide is your answer. Am I right, kids? Allyl iodide. Allyl iodide plus vinyl alcohol, right, kids? Allyl iodide and vinyl alcohol is the answer. I hope that it's very much clear to each and every one of you. Now, only one note I'm going to give you, kids. Then the lecture. After that note, one question will get over, right? Is it clear, kids? But before giving note, I would like to give one more question. Sir, what are you doing? You are giving many questions. Yes, kids, because cleavage of ether holds a hell lot of weight. It's very, very important. Very, very important, my dear friends. Now see. Tough question. Question for top 50 rank. But before I give question, do let me know that you are really enjoying, kids. Do you think that Baba is just teaching like a paid batch and better than the paid batch? Baba is just teaching for free of cost, and free of cost means once you are going to become doctor, you have to serve for the nation. You have to be a very good human being, not like fake doctors, fake academies. Just like Baba is a true teacher, you have to become a true doctor. You have to promise. Yeah. Now, question is saying, yes, very good, very good. Here is your question on your screen. Fast kids, fast. जल्दी जल्दी बताओ बच्चा लोग. Yes, how they can. Wow, shall we sing? Thank you, thank you. SN1, what's the reason? Definitely ABN and SN1. What's the reason? What's the reason that here no dancing resonance? 11, no dancing resonance. You see, for dancing resonance on the adjacent there should be carbon, but there is no carbon. This reason is aromaticity. You see, no dancing resonance. This compound is aromatic. Why it is aromatic? The ring is planar. Ring is planar. First thing, ring is planar. Second thing, following Huckel's rule. It is following Huckel's rule. Why? It is having 2 pi electrons. So it is aromaticity is there. Aromatic. It is aromatic. Got it? Always remember that for dancing resonance, the compound should have this cyclopropyl and here carbon. This is required for dancing resonance. Necessary condition for dancing resonance. Now, Baba is going to give you that note and then one question, then the class will get over. Sir, for the last 1 hour you are saying like this and you kept on teaching. Okay, that note is if hot concentrated Hi has been taken, then the alcohol formed during the reaction will react with excess of Hi to undergo ABN, acid base neutralization. But here I would like to say one point, that that's very good, 1111, that phenol will not react with Hi, because phenol will not react with Hi. Why, kids? One reason is that phenol and Hi both are acid. Hi is also acid. Phenol is also acid. So acid can't attack acid. The second thing is that this is sp2 hybridized carbon. So this bond is very, very stable bond, strong bond. This bond is very, very strong bond, sp2. So its single bond is having partial double bond character. So cleavage will not take place. This bond is very, very strong bond, very, very strong bond, very, very strong bond. So it will not break, it will not break, right, kids? Very, very strong bond. This bond is very, very strong bond. These are the two reasons. So last question, and after this the class will get over, right? Anisole, and after giving this question, I will give one long question, that is homework. You have to answer it in the comments. Sai Ramak, I was watching the hydrocarbon lecture now and I just saw this. Will watch the later, sir. Your videos are helpful. Thank you, Sai Ramak. Very good. Now, anisole plus hot concentrated Hi in excess will form what? This is the last question, live question. Then after this, one long question, which the answer I want to see in the comments. Shall be seeing 1111 is continuously giving the answer. Rest of other people are giving the answers. But I want to see the dedication, just like these people, that every time they are solving questions. These people are solving questions, not everyone. Now, what is the answer, kids? So for this, you should know what is anisole. If you don't know anisole, you won't be able to give the answer. So this is memory based, that anisole, this is anisole. SN2 reaction will take place. Very good. Some people will get confused over here. They will think like that is there is resonance. But remember that plus charge is never stable on double bonded carbon. Remember that. It will always remain localized. The plus charge is highly unstable. Are you getting my point? GOC highly unstable. So your answer is phenol plus methyl iodide, and phenol will not further react with HI. This is the answer, right? Assuming no idea, I will ask. I'm asking number of teachers to help you in bio and physics. Let's see who can help you, okay? Assuming. Now, question for your homework. Homework question is coming on your screen, right, kids? Thank you, 1111. Assuming tomorrow, coordination chemistry. So you people are supposed to find out I. What is I? And you have to answer it in the comments, right, kids? Will you do that? I want to see your answer in the comments. Kids, is it visible to all of you? Just see whatever is behind me. I have shifted a bit over there. Just see, is it visible to all of you? Oh, don't disclose the answer. That I want to see in the, oh my God, salute. Salute. 1111 now, though, I have told you will become pro. Don't worry, that day you remember. 1111, do you remember that day? And I have told you that day that one day you will become pro. Shall we sing 1111, your consistency is the reason for your success. That today you have seen Salvi saying 1111 and other students that you are feeling awesome, fully confident that yes, Baba, too much change is there, too much gaining of the concept. The proper revision is going to help me a lot. Everyone, really, you're feeling awesome, blossom. The questions are looking easy peasy, lemon squeezy. 1111 has to answer it right now. I can understand what is the answer. That 1111 has given the answer. Salvi Singh even can give the answer. I know that. You are pro. You have become pro because of your revision, because of your proper consistency, each and everything. Bye to all of you. Take care. We'll meet you tomorrow with coordination chemistry of NCERT. The whole NCERT in one shot coordination chemistry I will teach you. I will let you know each and everything. So, good night. Shabba khair. Take care. All the best. Dhanyavad Alu. Bye bye to all of you kids. Right, kids? Okay.